as you all are aware that we are covering programming in C++ in the form of a series of lectures. So within that series, today's topic is pointers. So we are going to cover basics of pointers. Now in order to understand in kind of very simple language what actually a pointer is, so the simplest idea we can say a pointer is an address variable. A pointer is a variable which is going to store the address of another variable, or to make it more kind of a bit more technical, we can say pointers are symbolic representation of addresses. Now the key question here is, within our series of introduction to programming in C++, in the previous lectures we have seen functions, and that function part is not over yet. So why are we learning pointers at this point of time here? So basically the next topic for functions is call by value and call by reference. That is the idea how parameters are being passed into functions. So when we go into greater depth and see how and why and through which kind of way we are going to pass parameters into our functions, so then there comes pointers. So if we want to study that parameter or argument passing into functions, pointers serves as a basic need over there. So that's what the idea, that why are we covering pointers here. So basically pointers, as I told you, are kind of variables. We can say they are a kind of a special variables because they are not going to hold any specific data value given by a user. Instead they are going to hold the variable of the address of another variable. So pointers basically are symbolic representation of addresses, we can say. Now what all can be done using pointers? So first idea is with the help of pointers one can create and manipulate dynamic data structures. And the another kind of utility of pointers is they help a programmer to implement call by reference, and call by reference is the keyword for kind of this lecture, which is we are going to that's the mechanism which we are going to cover in the kind of our upcoming lecture. So we are going through pointers at this stage in our course. Now if you remember, generally how do we declare a C++ variable? We say the data type and the variable name, and as the pointers are a kind of we can say special variables, so it is very important to tell your compiler that the that the variable which you are going to declare is the pointer variable. So pointer variables are also they hold the restriction that they needed to be kind of declared before they are being used, as other variables hold these restriction. So as pointers, and the kind of the way in which we can declare pointers is we will write the data type, then we will put a asterisk sign, and then we will write the name of the variable, the name of the variable or name of the pointer variable. So for example, I am going to give integer asterisk ptr. So integer here is the data type. Asterisk is a kind of, you can say, kind of symbol which is going to give your compiler the indication that the variable which is declared, that is ptr here in this case, is not a normal variable. Instead it is an pointer variable in which ultimately address will be stored. So if we are going to declare it as integer asterisk ptr, we cannot say ptr is equals to 10, because that's not a memory address, or even if that's a memory address, we are not supposed to assign memory addresses on our own directly. So integer asterisk ptr is one kind of, we can say, declaration or the syntax through which C++ compiler is being made aware that yes, ptr is a pointer variable. Now coming to the data type, what data type I am going to say a pointer variable is having. So, for example, I am having a normal kind of a variable, a simple variable which is an integer variable, and I say integer x, or maybe integer x is equals to 10, and similarly I say integer asterisk ptr. So, what data type pointer variable will hold? The data type of pointer variable will be the same as that of the variable whose address pointer is going to store. For example, in my code, or in my this snippet of code, I am having two variables. One is integer which is x, and the value of x is 10. Another a pointer variable named as ptr. And how it is a pointer variable? This is simply indicated by just an asterisk sign before the name of the pointer. So, basically two variables, one integer and another one pointer. So, now in the upcoming scenario, or in the upcoming code, what I am going to do, I will take the address of x somehow and I will store that into ptr variable. Now, while declaring ptr variable, we have to be sure that what kind of address, or basically, or to be more specific, we can say which variable's address your ptr is going to hold. That is going to be the data type. For example, here I have planned that I am going to store the address of x into ptr. So, x is an integer variable, so as ptr is also an integer variable. Now, for example, I have declared x as a character. For example, char x is equals to some character. So, then the pointer variable which is going to hold the address of x will be of char type. So, the data type of pointer variable will be same as of which address this pointer is going to hold. That is the simple idea. If pointer is going to hold the address of an integer pointer, so pointer variable will be integer. If pointer is going to hold an address of a float variable, the data type of pointer variable will be float. If pointer is going to hold the address of a character variable, then the variable of the pointer will be char. That is the simple fundamental behind the data type of any pointer variable, and the asterisk is going to tell the system, or is going to tell the compiler that this is not a normal variable, but instead rather this ptr is a pointer variable. So, that is the idea. Now, after this declaration integer x is equals to 10 and integer asterisk ptr, now your compiler is very clear of these two, I can say, variables. The compiler understands that x is a normal variable, normal integer variable with value 10, and ptr is an pointer variable which is pointing towards an integer. To which integer, it is not being decided yet in this part of the program, but yes, finally it is going to point towards an integer variable. So, whenever I am saying point towards an integer variable, so that essentially means that it is holding the data of an integer variable. Now, how this pointers are working in C or in C++ or any other language, let us try to see this. Now, for example, I have taken a variable whose value is 10, and then I have taken one pointer variable integer asterisk ptr. The value which I have assigned is ampersand var, ampersand var. Now, here are two special operators. One is asterisk, another one is ampersand. They both are having different meaning. For example, ampersand var, ampersand means address of. So, the statement which is the second statement in this code snippet can be divided into individual statement. One says integer asterisk ptr, which is the declaration of a ptr variable, and that ptr is nothing but it's of type pointer variable, and it is pointing towards an integer. So, just integer asterisk ptr as we have done previously here, which is integer asterisk ptr, and then we can say ptr is equals to ampersand var. So PTR is equals to ampersand where, that means the value of PTR or whatever value this PTR variable is going to hold is the address of where. So ampersand means address of. So integer asterisk PTR is equals to ampersand where, that essentially means that the address of where is being stored into PTR, and as per the declaration compiler allows it, because you have already told the compiler that PTR is going to be an kind of pointer variable and address variable which is going to store the address of any integer variable. So that's perfectly fine for your compiler. And then now you can see that you can imagine a link between kind of where and PTR. So assuming as given on the screen that the value of where is 10. So now with every variable there are associated three values. One is where, the name of the variable, another one is the value of the variable, and third one is the address of the variable. Now why we tell that pointer is in kind of symbolic address variables, because we are actually not aware of the actual addresses. So I have assumed here that the address is #2008. So address is what? So address is basically, you can say, the cell number in memory on which this VAR is being stored. Now on which particular memory location any variable is going to be stored, as a user I don't have any control on that. So VAR, so three things with a variable, with any normal variable I can say. One is the name of the variable, here I have taken it as VAR. Another is the value, which is 10, and third one is the address. Now this address actually is in the form of an hexadecimal number, which is not possible for us to recite it or something like that. So I have taken a symbolic address which is #2008. Now if you can see what is the value of PTR variable. Value of PTR variable will be #2008, because PTR is a pointer variable which is pointing towards this where. That means the address of where is going to be the value of PTR. Now you please imagine two variables, one is PTR, another one is where. These are the names. The value of where is 10, while the value of PTR is #2008. The address of where is #2008, and the address of PTR is some such X, I can say, because I am not aware of what kind of address my kind of memory or my system is going to assign, which particular location my VAR is going to be assigned. Now whenever I say asterisk PTR is equals to 20, so I am using another one new operator, which is the asterisk operator. So asterisk exactly means value at. So asterisk PTR is equals to 20, that you can read as value at PTR equals to 20. So value at PTR, what is the value of PTR is #2008. So the whole sentence become, or the whole instruction become, value at #2008 is equals to 20. I am repeating, value at #2008 is equals to 20. What does it mean? This essentially means that value of VAR has now become 20. Now the beauty of the statement here is we have not used the name of the variable, which is VAR, and yet we are able to change the value of the variable. I have taken asterisk PTR is equals to 20, that means value at #2008 is equals to 20. That means the VAR has now been assigned the value 20 instead of 10. So without using the name of the variable VAR, I have changed the value of VAR just by having one pointer in my hand. Now you can imagine that whatever you want to do in case of kind of these dynamic memory allocation scenarios, you can I mean with the help of pointers you can do wonders or you can do disasters with the memory. Both kind of things are possible. Now if I am going to say asterisk PTR is equals to 30. So asterisk PTR is equals to 30, that means now the variable is having value 30 instead of 20. So this you can do. So the important thing here is declaration of a normal integer variable, then declaration of a pointer integer variable. Third step will be assignment of address into pointer variable and then accessing the value of the variable with the help of pointer without even touching the original name of the variable, which we have done just now with the help of asterisk PTR equals to 20. So here is kind of another example which I was showing, which I was telling that there are addresses which are in the form of hexadecimal format. So addresses, yes, are in the hexadecimal format. So here two variables which I was explaining, VAR1 with normal value 10 because that's an integer variable, and it is having some address which is 0x7FFA075 and some kind of an address in the form of hexadecimal string. So that address is the value of PTR, if you can see on the screen, that is 0x7FFA0757DD4. That's the value of PTR. That means there is an kind of, I can say, virtual or symbolic link between the two variables starting from pointer to VAR. That means your pointer is pointing towards an VAR. So whenever I am saying pointing towards, that essentially means there is an address kind of storage, we can say. And here if you can see, there is a different address of variable pointer. So that's perfectly possible because, and that's desirable too, because each and every variable is given an address. So yes, pointers are also variable, although special variables, but basically as an identity we can say yes, they are variable. So they will be having their own address. So with PTR also you have three things associated. One is the name, which is PTR. Another one is the value of PTR, which is the address of VAR, another variable, and the address of pointer variable PTR itself. So with every variable there are associated three, we can say three things. Now if the address of pointer variable PTR, that I am going to store in some another kind of a variable, let's say P1. So now P1 is a pointer to the pointer, so that's also possible. We can have pointer to the pointers, and then with using pointers to pointers also we can access the value of VAR without using its original name. So yes, I mean many things are possible looking at dynamic memory allocation scenarios. We can do lot many things with the help of pointers if we want to, if we expertise them. So this was the fundamental principle behind your pointer, that's an address variable, or we can say a normal variable which is going to store the address of another variable. So here a complete kind of code snippet which you can write within your main along with your hash include iostream.h and using namespace standard. I have taken a variable VAR20, then a pointer variable asterisk PTR, and within PTR I am storing ampersand VAR. So ampersand I have told you is address of. And now if I am going to, let's say if I am going to go to print what value, if I am going to print PTR, so what is PTR? PTR is having the value which of the address of variable variable var. So if you print the value which is inside the ptr or value of ptr, I can say that's going to be the address of var. If we are going to print the value of var, simply we are going to get 10. And if we are going to kind of, we can say a value at ptr which is asterisk ptr, so asterisk ptr is nothing but 10. So here you can see the output, which is now depending upon which memory location your compiler or your system is going to allocate to your variable, according to that this address of var, which is the value of ptr, will change. You will not find the similar value of the address. So value at ptr is some address on which var is being stored. Value at var is 20, and value at asterisk pointer, that means value at that address 0x7ffc, whatever the address is also 20. So here is the, we can say kind of basic of pointer variables. So in order to summarize how are we going to use a pointer variable, so first of all we will be defining the pointer variable with its proper data type, I can say. After defining the pointer variable, the idea is to assign the value. And what is going to be the value of a pointer variable? That is nothing but address, and that address of any variable I am going to catch hold of by using unary operator ampersand. So if I am saying ampersand x, that means address of x. If I am saying ampersand y, that means address of y. So that address of x or address of y or address of any other variable for that matter will be stored inside the pointer variable, and then after this we can access the value stored in that variable, which is x or y, by just using the name of the pointer and by using the unary operator asterisk. So value of the variable located at the address will be specified by this operand, which is asterisk, and thus yes, we can access that particular value too. So that was, I can say, basics, very kind of very basic fundamentals about what actually a pointer variable is. Now coming to why we associate a data type to a pointer is basically a pointer always store address into that. So why do you need a specific data type to be associated with pointer, that whether this is pointing towards an integer variable or whether it is pointing towards an character variable or float variable or any other. So basically this data type is going to help us in pointer arithmetic. So for example, I am saying pointer plus plus. So whenever I am saying pointer plus plus, that means pointer is equals to pointer plus 1. So that is going to jump to the kind of next location of its type if I am talking about arrays. So or just to make it simple, I can say by associating a data type to a pointer, it knows how many bytes the data is stored in, and whenever we increment a pointer, we increase the pointer by the size of data type to which it points. So for example, if I am going to increment a pointer ptr which is pointing towards integer, so the increment will be of 4 bytes. If I am going to increment a character pointer, the increment will be of 1 byte, and if I am going to increment a float pointer, the increment will be of 8 bytes. So that's what the idea is. But here in order to continue our lectures and in order to continue focus on our function thing, we need not to go into the into more details of pointers or pointer arithmetic. Just let's see what kind of pointer arithmetic is permitted. We can increment a pointer or we can decrement a pointer by increment or decrement operators, plus plus or minus minus. We can add an integer to the pointer. An integer may be subtracted from a pointer, and we can find the difference between two pointers. So that's all kind of pointer arithmetic is actually which we are allowed to have. So hope you have got the basic kind of fundamentals of what actually pointers is and how are we going to use it. So here is a list of references which is being used in making this lecture up. I hope you have good hearing. Thank you.